Hello everyone, welcome to the solutions for COMP2605 Oracle Lab 3. I'm going to go through each of the 17 questions step by step, and for each one I'll read questions first, then share the SQL query or command that solves it. I'll also add a quick explanation of the key concepts to help you understand why it works. So feel free to pause the video and try running these in your Oracle environment. Okay, let's get started. Question 1. Display for each employee the employee's name and the number of days, weeks, and months that the employee has been employed with the company using SysDate. Let's take a look at the solution. So we see here the solution is select ename SysDate minus hire date, SysDate minus hire date divided by 7, months between SysDate hire dates from employees. This uses SysDate here to calculate the current date minus the hire date for days divided by 7 for weeks, and uses the month between for the function for the months. So remember, SysDate is Oracle's built-in current date function. Question 2. Display each employee's name, department number, and department name to which the employee is attached. Let's take a look at the answer. Select employees.ename as employee name, department.departmentnum, department.department.dname from employees department, where employees.departmentnum equals departmentnum or department.departmentnum. This is a basic inner join using the where clause to match department numbers. So we're using the table aliases in the select for clarity, but full table names in the from. So we see here we're using the full table names here, right? And we're just connecting it to the actual fields so we know which department number we're referring to. Question 3. Using table aliases, display for each employee located in the POS office their name, hire date, and job title. Results should be ordered in descending order by the hire date. Let's take a look at the answer. Select e.ename as employee name, e.hiredate, e.job from employees E, departments D, where e.departmentnum equals d.departmentnum and LOC or location equals New York, ordered by e.hiredate in descending order. So the question says Portsmouth office, but based on the standard schemas, this will refer to New York. You just need to adjust it. You just need to adjust the data to suit the location that you're looking for. So the table aliases E and D. We would recognize these here right after the table names being referenced. These make it cleaner. These make the query cleaner itself. Okay, so instead of saying, as we would have seen in question 2, where employees.departmentnum, we have here e.departmentnum, which is simply an alias for the employees table. Question 4. Display for each employee the employee's name and job title as well as the name of their manager. Let's take a look at the answer. Select e1.ename, and then we have where we declare that we're going to put in a string as employee name, e1.job, e2.ename as manager from employees e1, employees e2, where manager e1.manager equals e2.enum or empnum, sorry. This is what you call a self-join on the employees table, where E1 is the employee and E2 is the manager. They're linked by the manager column. We're assuming that ename is a full name. No concatenation needed unless it's a separate last name field. Okay. Let's take a look at question 5. Question 5. Repeat the query above so that all employees are now included in the result set. Use the outer join operator. Here are two ways that we can do the outer join. Let's take a look at it. First off, we have select e1.ename, e1.job, e2.ename from employees e1, employees e2, where e1.manager equals e2.empnum. Alright, so we're using the operators here. Okay. So the two ways to do the outer join, one for the left outer join and one for the right, depending on how you want to include the non-managers. So first, select e1.ename, e1.job, e2.ename from employees e1, employees e2, where e1.manager equals e2.employee_num. Then we have the join function here. Second, select ename, e1.ename, e1.job, e2.ename from employees e1, employees e2, where e1.manager equals e2.employee_num. The plus operator in Oracle indicates an outer join, including rows where there's no match. For example, employees without a manager. So we can try both to see the difference in the results. So if you notice here, at the end of this line, you have the plus operator, and at the end of this line, you have the plus operator here. So you can try both configurations to see exactly where, what results you get. Question 6. Display for each department the department name and the number of employees in each department. Let's take a look at the answer. It's fairly straightforward. Select the name or department name. You're going to count the employee numbers from employee E, the alias E for employee, department D, D for the alias for department, the department table, where E.department_num equals D.department_num, and you group them by D name or department name. Okay. So this joins the tables and groups them by department name, as we can see here, right here. Okay, the join is from the where, and they're grouped by name, and it uses count right here. It uses count to tally the employees. It's just simple aggregation. Okay, it's just a simple aggregation function. All right, let us move on to question 7. Display for each department the total employee's salary and the average employee's salary. Let's take a look at the answer. So this is again fairly simple. You have select sum of the salary, average of the salary from employees and department table. You have to bring them together, where employee or E.department_num equals D.department_num, and you're grouping them again by department name as the previous question asked, right? And what we're doing right now, we're just giving the total salary and the average salary. So this uses a sum, like we just see here, for the total salary, and obviously the average for the average salary here, and it will just be grouped by the department. Let's take a look at question 8. Display the department name, number of employees, and the sum of salaries for all those departments where the number of employees is 5 or more. Order your results in descending order by sum on salary. Let's take a look. Okay, so this may look a bit complicated, but it's really fairly straightforward. So the query goes select department name, counts employee numbers, sum salary from department employees, where department.department num equals employees.department num, group by department name, having count employee num greater than 5, and then you order it by sum of his salary in descending order. So we use the group by for departments having to filter groups with 5 or more employees, and order to sort by total salary in descending order. Let's take a look at question 9. Run the script. Lab3 script.sql to populate the product table from Lab2. Create and populate the customer and orders table. And note that all tasks from Lab1 must be completed for the script to execute successfully. If you're unsure, run the Lab1 tasks.sql. This is just running the script provided, so make sure the path is correct and execute the files in Oracle. By doing this, it's fairly simple. Let's take a look at question 10. Create a synonym cust for the customer table. Okay. So this is how we do it. Create synonym cust for customer. So synonyms just like you use shorter names for tables. They're very handy for long queries. So this is how we write, or we create the synonym for customer. Right, just create synonym cust for customer. Alright, so now we want to, in question 11, we want to query the customer table using the synonym we just created. So that will be simply select all from customer or from cust. This selects all the synonyms which point to the customer table. Let's take a look at question 12. Return the order ID, customer name, employee name, and order dates of all orders made on or before June 1st, 1986. Let's take a look at our solution. So we want to select the order ID, the customer name, employee name, order date from customer C, this is the alias, orders O, again that's the alias for that, employees E, again it's another alias here, where C customer ID is equal to O customer ID and E employee num equal to O employee num, and order date is less than, and we're going to have the 1st of June 1986, and don't forget we have to put this into the form of this by using the toDate function, which is declaring what we want to make it. So we have the multi-join table with the date filtering and using the toDate for just proper formatting. Right? That's a good question 13. Create the order details table with the following specifications. Table order ID number 3, not null, this is the primary key. The foreign key referencing orders, product ID, varchar 2 with 5, not null, primary key, foreign key referencing product, quantity orders number 3, not null, must be greater than 0. Okay, let's take a look at the answer. Obviously, we're using the create table instruction. Create table order details. Don't forget your opening brackets, your opening and closing brackets. Order ID, type number, value 3, not null, product ID, varchar 2, and size of 5, not null, quantity ordered, type number, size 3, not null, check, quantity ordered greater than 0, foreign key, order ID references the orders, order ID in the orders table. The foreign key is product ID here, references the product table or product ID field. The primary key is order ID, product ID. So this is what you call a composite primary key, where you have two unique values that create the primary key. So this is composed of the primary and the foreign keys, which will maintain referential integrity. Take some time to look at this table and try the question again if you do not get it right. Let's take a look at question 14. Insert a row of data in the order details table representing that 0 of product F4MPP was ordered in order ID 15. Run the script inst.od.sql to populate the order details table. So that to get that done, we go to insert into order details values 15 F4MPP 1. These are the values that we're required to run, right? The question says quantities. The question says 0 quantity, but the check constraint requires greater than 0. So it uses 1. Okay, so you have to include 1 here so that it doesn't violate the constraint that is on the table itself. And the next thing we do is we run the script for the order details table. Let's take a look at question 15. Return the product name of all products ordered by customer Crystal Lewis. Let's take a look. Select product name from product table P as the alias, order details OD as the alias, orders O as the alias, and customer C as the alias, where c.custName equals Crystal Lewis and c.custID equals o.custID, and order o.orderID or order ID equals od.orderID, and od.productID is equal to p.productID. So we have a four table join filtering by customer name. The 4 tables would be obviously product, order details, orders, and customer. This is important when you creating things like invoices and those sorts of things. When you need all of these details from a particular query, you see that you have multiple tables here being linked, and using the equal operator here to find the specific values that you're looking for, and pulling out the records that belong to this particular customer and customer name and ID, and matching it with the orders for the customer, the order details of that order, and the products that are related to that order. Okay, let's look at question 16. We want to display the order details of the order with order ID 20, showing the following data: product ID, product name, unit price, quantity ordered, item cost. So a hint is to use item cost equals unit price times quantity ordered, right? We can take a look at lab 2 for details on the product table. Let's take a look at the answer. So here we see we select the product ID, product name, and unit price, quantity ordered, and then we're gonna have a calculation with a label: unit price times quantity ordered as item cost. So remember, in the previous lab, we would have had things like sal times 12 to give us the annual salary, right? So it's the same concept. We're just multiplying 2 variables here, and then in this case we're just going to put a label on it by using the and keyword, the as keyword, sorry. Alright, so these are called calculated columns, calculated fields, right? So the same as when we did sal times 12, that was not an actual field in a table. In that table we had sal as a field, but which represented the monthly salary, but we did not actually have the annual salary for employees, right? And so to get the annual salary for employees, we would have had to have typed sal times 12 to give us the annual salary, but that's a calculated field, and it's not actually stored in the database. Okay, let's take a look at our final question. So for all orders, show the order ID and the order totals. Order totals using an aggregate function. Order the results by order ID. All right, let's take a look. We have select order ID. We want to sum, or this is our aggregate function. P.unit price times OD, or order details, dot quantity ordered as subtotal from product P, again the alias here. Order details has an alias of OD, where order details dot product ID is equal to product dot product ID, and then we're going to group them by order ID. Okay, so the alias is a subtotal here. Okay, so remember we spoke about the calculated field, like this one, right? And in this case, we're going to have the alias as subtotal, but it could be changed to order totals or anything that you'd like, right? And then you group it by order ID, and this sums in line total, the line totals. Okay, all right. So please feel free to review all the questions or any of the questions you might be having problems with, and tackle the questions, and we will see you in class. All right.